Hello, welcome to Power System Fault Section 2. We will learn to calculate three-phase fault current at substation. In physical system, there are many generators connecting to substations. However, they could be modeled with one voltage source and the equivalent impedance. Suppose three-phase fault occurs at the front of substation at the output side. Two parameters are specified. There are short circuit capacity or SCC and voltage rating. Then we can calculate short circuit current from this equation and calculate equivalent impedance from this equation. Example 1. Short circuit capacity at substation is 100 MVA. The voltage level in the substation is 115 kV. Let's find short circuit current and equivalent impedance. Short circuit current is obtained by replacing these values in this equation. Short circuit current is 502 amperes. And equivalent impedance can be calculated by this equation. It is J132 ohm. Assume equivalent resistance is 0. There is only reactance. The voltage level at this substation is 33 kV. Short circuit current is 1.75 kA. Let's find short circuit capacity. We can calculate the short circuit capacity from this equation. It is 100 MVA. The rating of this three-phase transformer is 1000 kVA. High voltage side is 24 kV, whereas low voltage side is 415 volt. Impedance is 6%. This transformer is connected with 24 kV feeder. Short circuit capacity at the point of connection is 100 MVA. If three-phase fault occurs at low voltage side of this transformer, let's calculate short circuit current. The equivalent impedance at the point of connection can be calculated from this equation. It is J0.00173 ohm. Transformer impedance can be calculated from this equation. It is J0.01038 ohm. Short circuit current at low voltage side can be calculated from this equation. It is approximately minus J20 kA. Alternatively, we can calculate based on per unit system. Base power is 1000 kVA and base voltage is 415 volt. Then calculate base current from this equation. It is approximately 1388 ampere. Equivalent impedance at low voltage side in per unit can be calculated from this equation. It is J0.01 per unit. We can calculate short circuit current at low voltage side in per unit from this equation. It is minus J14.29 per unit. Then convert per unit into the actual value by this equation. The magnitude of short circuit current is approximately 20 kA. Alternatively, we can use this formula by using transformer rating as base unit quantities. We can calculate short circuit current in per unit from this formula. Use data in example 3. Short circuit current is minus J14.29 per unit, which is the same result as mentioned in solution 2. In conclusions, normally, short circuit capacity and voltage level are given. We can calculate short circuit current and equivalent impedance from these equations. In case that three-phase fault occurs at transformer, we can calculate short circuit current in per unit from this equation, which use transformer ratings as base unit quantities. Thank you for your attention. Please stay tuned for more clips.